So let's assume that you've gotten through chapter 3 in the book. Um, you can get that from just a free sample of the book. So if you read the free sample, or if you bought the book and read past chapter 3, you know enough to be able to start modeling with types. I don't go into the detail I'm going to go into here in the book when it comes to modeling types. We sort of model types as we go along, but this is additional information to the book. Okay, so when you're modeling something, you're basically being very scientific about the thing that you're trying to model. So the very first thing you want to do is make sure you understand the thing you're modeling. That's the first thing. You can go too far on that. You can try to understand absolutely everything about the subject matter, and most of it will probably be outside of your interest. In other words, the way in which you look at something when you're modeling it is highly dependent on the application at hand. So while an attribute of an object is important, it isn't as important in one application as it might be in another. So we're going to do we're going to model a kitchen, since everybody has a kitchen and we all are fairly experts in kitchens. I kind of want to start where we're all an expert already, and kitchens are pretty similar to one another. So I want to start there, and I want to imagine that I'm mostly concerned about remodeling a kitchen, let's say. Okay, so that's my restriction. I don't really care about um, certain certain attributes of things that go in a kitchen that might have to do with keeping inventory of kitchen items. For example, if I was making an application or trying to model a kitchen or kitchen appliances for a store, that's a very different model. There'll be some overlapping to what we're going to do, but it's a very different model. Certain things are important. For example, let's say for a refrigerator or a dishwasher, how much energy it uses over the year would be very important in a database of lots of dishwashers and lots of refrigerators. So we want to make sure that we don't over design our models. I used to do that a lot early in my career, and for a very large part of my career. You can under design, and that's equally bad. But I don't know, maybe over designing is worse. Who knows? We want to avoid both. So we want to try and make sure that if we only care about remodeling a kitchen and keeping track of what's going to be in this new kitchen that we're going to build, we want to make sure that we don't have things like energy usage as a parameter here. Not important because we're not comparing two dishwashers side by side. So what you want to do when you're looking at things is you want to look at the nouns. You want to see what the nouns are in this, in your world. Our world is kitchen, and so that's the universe of what we're going to work with. And we want to look at what the nouns are, and then once you have a noun, you want to look at what the attributes of that noun are, and that's the important thing. So, and the salient attributes, that is, the attributes that are going to impact our particular application, only the things that we care about. So like I said earlier, we don't care about the energy efficiency, but we do care about the, say, I don't know, the cubic feet in a excuse me, in a refrigerator, for example. We might care about that. So okay, so let's get started. I have a project open up in VS Code. I'm going to come up to source and create a new folder. I'm going to call it data. Whoops, try that again. Data. Okay. And then I'm going to create a file called kitchen.pers. Okay. So, and right off the bat, you got to type in your module. Right here, I tend to just follow after source. And this tells me what to type, basically, the path to this. So you tend to follow the path within, it's not totally required by the compiler, but it's a common practice. if you look at any of the PureScript libraries and such. And I think it might be required in Haskell. I don't know. I just tend to always do it, so I don't know if I can get away with not doing it. So you sort of want to follow the path, starting with your root. The source is the root here. So the very first thing is data. So we're going to go module data dot, and now the next thing in path is kitchen. So we'll do that next. And then that's my full module name. Okay, and I can save this and it will compile. So if you're doing this in Haskell, I think I'm not sure if it compiles with just that, but this is enough to compile, or is it Elm doesn't? So either Haskell or Elm, I believe, that's not sufficient for the compiler. But in PureScript it is. Okay, so we're going to start with the largest object, and we'll just keep drilling down into smaller and smaller things. And so the very largest thing is the kitchen itself. So there aren't, since I have one kitchen that I'm remodeling, it's not really gonna be a sum type, because a sum type is typically A or B or C. I mean, there's only one kitchen, and I'm gonna try and capture the attributes of that kitchen. So I'm probably gonna want to capture them. There's two ways you can capture them. But I can tell you right off the bat, I'm gonna want to capture them in a record, and I'll show you why. Let's say I create something and it's kitchen, and I want to know how many, I'm just going to capture the dimensions of the kitchen, okay? So I'm going to have an integer and an integer and an integer, and that's going to be my width, height, and depth. Okay, now granted, I can easily just say, okay, well, let me give it type alias for the type alias for these things, and then at least I know what's what, right? And I could do this, and let's see, width, height, and depth. Okay, so I could do that, and then I don't have to have int and be completely ignorant as to which goes where. So then I can do this, and I could do that. Okay, so that's okay, and it's better, and I know what goes where. A new type would be much better in this regard, and I'm going to do this. I'm going to take these guys, and so there's the new type itself, and then there's the constructor of each of those. And what that'll do is it'll guarantee that I can't, because before when we had them as type aliases, it'd just be int, so it's just another name for int, and they can be interchanged. Here they can't be. Width has to go in this position. So that's a way I could do this, but every time I want to add another attribute, I got to put something else here, right? I have to put another thing here, and it becomes a bit much. Now, this is what's called a product type, because you have width and the height and the depth all together, right? It's not width or height or depth. It's ands. So it's a product type. And product types tend to work best once you get beyond 2 as records. So I'm going to change this to be a record, okay? And one of the things I want to do is just think about the kitchen in general. I'm going to get rid of these. I don't need these anymore. Okay. Now, just want to think about the kitchen in general. I want to ask a very important question. Okay, what makes up a kitchen? Well, there's lots of things that make up a kitchen, but what are the salient things the things that we care about kitchens, right? We're remodeling it. Well, one of the most important things is appliances, right? So we're going to do appliances, and that's a single field in our record. And then I'm going to say, well, it's an array of this type appliance. I don't really know what that is yet, but let's start there, okay? Now I could keep going on and adding more and more things to kitchen. I tend to, that's not a bad way of doing it if you're on a whiteboard with a team, and you're trying to, brainstorm up the attributes of things. That can work well. I'm sort of ad-libbing it here, and I'm going to do it a slightly different way. I'm going to do this and then drill down to what appliance is. I'm going to keep since I'm working with a compiler, I'm going to keep the compiler happy. So if I were to save this right now, unhappy, right? There is no specification for that. So I'm going to go and define that. And then anything that defines, I'm going to define, and so forth. That's not the only way you can do this. You can certainly do it the other way around, where you just list out everything and then sit down and type in all the types. Okay, so let's think about an appliance. So an appliance has lots of attributes, right? One thing we could do is we could say, well, let's think about this: refrigerator, toaster, oven, stove, dishwasher, things like that. We could just say that's it, and they're just single types, right? And we just have a bunch of we have a sum type, right? A single appliance could be any one of those things, but that wouldn't allow me to store as much information on the thing itself, right? Let me show you what I'm talking about. Once again, if I did appliance like this, right? And I'm gonna do a sum type. So I'm just gonna make this simple. So I'll make it toaster and oven, okay? Just for an example. All right, so we have toaster and oven, and now I should be done, right? The compiler's happy, yay, okay? So let's pretend that's all we need. Unfortunately, I want more information on the toaster. So now I have to put information on the toaster. And let's say I want to know the dimensions of the toaster. So I'm going to create a thing called dimensions. And I'll do dimensions as a type. And now that I think about it, I kind of wanted dimensions on this as well, right? Okay, so let's move that down here too. We'll copy that. So now we have dimensions on both of those things. And imagine now I have a big list of appliances. This is a short list, but now I'm putting dimensions on everything. And I'm like, ugh, that's no good. I don't want that. No, that's not good. I want something that's common about all appliances to be captured some way. And the way you can do that, I mean, there might be other ways. I can't think of anyone right off the bat, but one really good way is you create an alias for this, and then you just would say dimensions. So these are the dimensions, and then dimension, like that. And then that's great, but then I don't know, like, is it a toaster? Is it an oven? What is it? So I'm going to create a type, right? So I'll specify a type. Now I have to put the underscore here because type is a keyword. Now I could put a tick as well, but I tend to just do underscore for keywords. So this would be appliance type, I guess. I'll call it that for lack of a better name. And okay, so now we have two appliances. The compiler is very unhappy. So let's get rid of, let's change this to appliance type, okay? All right, so it doesn't know what dimension is, but that's okay. I'm actually gonna get rid of this part, right? So I'm gonna get rid of, I'm gonna get rid of that, okay? So boom, it's gone. And now I have the type of toaster, the type is of this particular appliance is toaster or oven. Now, the dimensions are shared for every appliance. I don't have to pollute this data constructor with it. So that's kind of good. We don't know what dimensions are yet, but we'll get to that. So let's start listing out more things, right? So we have I'm thinking a can opener, right? You got a can opener, you've got a stove, you've got a refrigerator. How do you spell refrigerator? Boy, I hate that. How do you spell refrigerator? Oh yeah, refrigerator. Okay, so now I'm starting to look at this, and this list is going to get pretty long. And in reality, if you think about it, when you're remodeling your kitchen, yeah, you want to get a new can opener, but what can opener you get and the cost of it is nowhere near as important as things like the refrigerator and the stove and the oven and a microwave and dishwasher. Those are your bigger appliances, and little ones are like, coffee maker and things like that. So my thought here is, instead of having this just massive list, it might be good to split them up. And the reason I think it's good to split them up is because of how I'm more concerned about the costs of my larger appliances than my smaller ones, right? If something's going to cost, $5,000, then I'm going to really want to keep track of all the information about that thing, more so than something's going to cost $100. So let's just assume that. And let's split up the appliances into two types. Large appliance, okay, get rid of that for now. And we'll come up here and or small appliance, okay? And now I need, so that's a data constructor, but I also need more information. So there's a bunch of large appliances. So I'll create a type called large appliance. We'll define it in a minute, but I'll just assume that exists. And then small appliance. Okay, so we have that. Get rid of this for now. Okay, so we don't need that. So there's my appliance type. So now I'm, compiler's going to complain. It doesn't know what large appliance is. Okay, so let's start there. So it's going to be a sum type. That is, it's going to be a bunch of ors. Okay, so a large appliance is a refrigerator, or it's a stove, and so forth. So that's pretty much the process in this case, is to just list them out. So I'm just going to take a look at so I have a refrigerator. Boy, that thing's just killing me today. Okay, that's totally wrong. Rator. There we go. Cannot spell today. Okay, so let's see. A dishwasher, an oven, or an oven, or a stove, or a range, or a microwave oven. Okay, so we'll just call it microwave. That seems pretty good. All right, so now we'll do small appliances, right? So save it. I saved it, and the compiler moved to this small appliance since it doesn't know what that is. We'll do that one. So small appliance equals, let's see. Okay, what did I have? Toaster. We have a can opener. We have, let's say, a toaster oven. That's a thing, right? Coffee maker, I said. And blender. Okay, that's pretty good for now, right? If we think of something else, we'll add it. Okay, so that's sort of the process. You want to exhaust your brain of all the things you can think of. Doesn't mean we're done. That's not the definitive list, but that's a good starting point. We're going to go back and look at it time and time again. We're going to add to it, maybe even subtract from it. Maybe we added something here and we're like, that doesn't belong on this list. Maybe there's another type, like a medium-sized appliance, that we decide we'd like to categorize, create a new category. In this case, I don't see that being the case, but it can happen when you're modeling something. So your first model isn't always going to be the right model. And many times you do a model and you realize, this is not what I wanted, and you redo it. But at least you have something to work off of once you have something. So getting something down on paper is a good starting point. But don't stop there. The trick is to then ask critical questions of the model. Does the model hold up? Of the kinds of things I'm going to do with this model, is it easy to work with? You want to really suss that out really early in the process, because all things will be built on top of this model. Other models, code that you're going to write. So it's really important to get this part right. Okay, so the next step, I think, is, well, we shouldn't do what a dimension is, right? That compiler's complaining. So if I'm letting the compiler do the work and help me, I kind of follow the compiler. Okay, so I'm going to do that. Let's figure out what a dimension is. A dimension is going to have a couple of pieces of information. So I'm going to go to a record in this case. And so a dimension is equal to the width, right? And that's going to be, oh, I should have kept those, huh? Oh, well, no big deal. Let's type them in again. Width equals width. Oh, wait a minute. Not sure I want to do this. Yeah. So, I don't want to do int. I'm kind of thinking that what I really want is some kind of unit, right? So I'm thinking maybe I want to do something like this, right? These are my units, right? So I'd have a new type. Well, there's a couple ways you can do this. Okay, so that's one way. I could do dimension unit, right? Whoops, unit. So that would be a dimension unit, right? So dimension unit would be inches int or feet int. And unfortunately, I can't have partial feet here. I guess I can make this a number, and I can make this a number if I wanted partial inches. That's one way of doing it, right? And then these things would just be dimension units. Dimension unit, right? So that'd be a dimension unit. So that's one way I could do this. Dimension unit. And then this would be depth, let's say. Okay, cool. So that's one way of doing this. Another way is to do this kind of a thing where you have width equals width. I could do int or I could do inches here, right? Either one would work. Now, the reason it's complaining is I have inches here and inches here since I can't make up my mind. Let's, I don't know. Now, this is a hard one, right? So I'm not a fan of having a number here because now I have decimals to deal with, and yeah, I don't know about that. That's not horrible. This isn't accurate. Isn't going to be accurate for small things because they'll give you like 12 and a half. You'll get that half. So I guess I'm sort of stuck with this. If I were to do, it's possible like we could do something like this, equals feet in number. We'll do number here, right? And change this to number 2. So that'll be number as well. Okay, so those are 2 possible solutions. Think about it for a minute and see which one that you feel make the most sense here. Okay, so hopefully you had time to think about it. If not, pause. You paused it and thought about it. I'm torn. Either would work for me. This would work. Oh, I should have done this as well. Sorry about that. This would also work. So dimension unit would work, right? So that's possibility. So we either pick these 3, right? Or we pick this one down here with this dimension unit. I'm gonna go with the more complicated case because it's more flexible, yet it's not a huge burden on me. So I'm gonna just comment this out in case I'm wrong. So I don't know. I'm just guessing, right? I'm doing my best guess that this might be a better approach, and we won't really know till later. And we can pretty quickly make the changes. So I'm just gonna assume that this is a dimension unit of inches where you take a number, or feet and you take a number, okay? The one thing that I really like is we've got that, but yet we also wrap the units in width and height and depth here. And that helps us not switch numbers around accidentally. Depth, okay, great. Well, there's an issue here, right? The dimensions are on my appliance, but this is useful. I might want to know what the dimensions of my kitchen are, right? So dimensions, right? So do that as well. And, whoops, not dimensions, dimension. Actually, this should be an S, right? Dimensions. Yeah, these are dimensions. So I'll put an S there. It makes more sense. Okay, so now we're going to look at this. If I'm going to call that dimensions, then I should call these dimensions unit. So they're consistent. All right, so now the next thing I'm looking at here is going, well, wait a minute. Do I really care how tall my kitchen is? Probably not. Maybe I do for the cabinetry. But most kitchens are tall enough for all appliances, so we're only going to concern ourselves with appliances today. So what I'm going to do here is say that the height of my kitchen is immaterial. So one thing I could do is say, okay, well, I don't always need a height, so I could do maybe a height, right? And I could say, well, sometimes you have a height, sometimes you don't. And there, I'll make it a maybe. And I'm like, not so great. That's not so great. Because now I'm burdening everyone who doesn't care about height with the fact that I have to put a nothing in there. And if I'm storing this in a database, I have to store nothing. And I'm like, okay, that's no good. So another way I can do this is create a different dimension type, right? So I'll create dimensions 2D, and it will only contain, you know what? I don't like the word depth, length. Let's change depth to length. Okay, so length, let's fix this one, make that length. Okay, so this is just gonna be width and length, okay? So we're just gonna steal this stuff here and get rid of the height. Okay, so that's nice, but if that's dimensions 2D, this is clearly 3D, and so we have that. Now I'm duplicating stuff here, and I'm like, I don't really like that. That's kind of awful. And so let's see what we can do. This is already, all we're doing really, this is already defined, width and length, and I don't need to redefine it here. All I need to do is add height. So let's do that. Let's say that dimensions 3D is dimensions 2D, okay, with an additional thing, okay? So let's see, how can I do this without burdening the dimension? I could certainly put an R here for a row, and I'm pretty sure that you've seen what a row is, but if you haven't yet, a row is basically fields that can be dynamically added to records. No, not dynamically. Can be added to records when you're defining your types. So instead of having curly brackets here, you'll have parentheses. So this is the syntax for that. And you have this bar with an R, and that means that I can take this type and I can decide to add as many things as I want to it, right? As many other fields. So let's do that. Let's go through that. So we don't need width because we're already getting it from dimensions 2D, right? And we don't need the length because we have that as well. But this is going to change from curly brackets to parentheses now. Whoops. Okay. So now we have this row that's going to be added to the 2D. That's our R, right? This row here. And a row consists of a label with a type. And there's, you know, n of those things. So you can have one or many. Okay, so we now have this defined once, and we take the 3D, and we start with 2D, and we just add in this extra dimension. And so that's how you can do this, okay? So that's not bad. That's pretty good. Now, the dimension on the appliances is a 3D dimension because we care about the height of a refrigerator, let's say. We decided we didn't care about the dimensions of the height of the kitchen. So we're going to call that one a 2D. Now, notice what happened. Compiler's complaining. Okay, so it didn't complain on the 3D, but it's complaining on the 2D. Why? Take a look at the error and see if you can figure it out. Okay, so let's think about this. Dimensions 2D. Let's look at dimensions 2D. Well, it takes a type parameter, R. Did we provide a type parameter here? Nope. And that's exactly what it's complaining about, saying could not match something that is going to take a row type, that's our R, and return a type with some kind. These are kinds, right? Types have, like, data has a type called a type, and types have a type, if you will, called a kind. So there are different kinds of types. There are regular old types like int and number and boolean, things like that. And then there are these things, row types. They're different. They're called row space type, as we see here. So it's expecting one parameter, and when it gets that parameter, it's going to return this type. And that's what this little arrow thing is, right? So it's kind of telling us, hey, dimensions 2D is kind of like a function at the type level, and it's expecting this parameter, and we didn't give it a parameter. So it wants to basically know, what is our R over here? What extra fields are we adding? Well, we want this to be a two-dimensional thing, and so, we're going to do that. Well, that kind of stinks. Everywhere I have a dimensions 2D, I have to have this empty row, right? All right, so let's fix that. I don't like that. So I'm going to do this. I'm going to say that this is dimensions common. Okay. So that's the common stuff for both 2D and 3D. I'm going to make 2D be dimensions common. And then I'm going to do that, right? Give it the empty. I don't have to do it once. I don't have to do it every time I use it now. So I can get rid of this. That's nice, right? And then this guy is going to be not dimensions 2D anymore because that's concrete. This is one that can be expanded with this R, with the row. So we want to call it common, right? So now we have our 3D starts with our dimensions common and adds the height. And our 2D starts with the dimensions common and adds nothing. And now we can just say 3D and 2D everywhere, and we're not polluting our code with this extra bit, this extra parameter, okay? So it's just, this is a way in which you can factor out stuff from your types, okay? So that's an improvement. I'm happy with that. Okay, so where are we? We've got dimensions on our appliances. We've got dimensions on our kitchen. And now I kind of, I'm starting to think, what other information is important for the appliances, right? Because I feel like we started with the kitchen and we're drilling down to appliance. Are there other things here that I'm going to care about? So let's see. I don't know about this. So what else might I care about? Oh, I'm remodeling. Right, so let's go back to our spec, right? We're caring about remodeling. So let's think about what you might go through. You're remodeling your kitchen. What do you want to know? What do you want to capture about your refrigerator as you're putting this thing together? Well, let's assume you want to capture the cost of that device because you're going to be budgeting or something, okay? So there's another piece of information here that we're going to care about, and that's going to be the cost of it, right? And so that's a common thing. And so let's add that. So cost, and then what do I put here? What type do I put for the cost of something? So I'm going to say, well, it's a number, right? Because most, I'm in the US, but most currencies have fractional values, right? So you might have, like in the United States, you have $10 and 34 cents. That would be a very cheap refrigerator, but there you go. So $10.34, right? So a number is going to capture that, and that works nicely. However, I don't want just anybody to put any old number in there, and so I'm going to protect that with a money type. Right now, this is not capturing the currency at all. So I'm imagining I'm doing this in the United States, but if I was doing this in some other country, then this application would, like if I'm a remodeling company and I'm using this application that I'm about to build here, I know what my currency is, right? It's an implied currency because I only work in one country. So we're just going to pretend that's the case here because this is just for learning. So I'm going to change that to be money, okay? So we can't accidentally get just any number, right? We can't get the inches number and somehow cross our wires and put it in the cost, right? So that's why we protect them with these new types, right? Yes, this is a number, but you have to have inches or feet in front of it, which are our units. And then you've got to wrap it in the right thing depending on which dimension we're talking about. Same thing here with money. I don't just want somebody to just put in randomly any number, especially if you're calling some function, right? So let's imagine we're going to write a function called compute tax. And it's going to take a money and it's going to return a money, right? So you're going to give it an amount and it's going to return the amount of money you have to pay in taxes, okay? So compute, if I was doing something like that, I want to make sure that, let's say, here we go. We have the tax rate, okay? So I'm going to take the tax rate in as a number, okay? Now, this is a great example of where you can get your wires crossed, right? So I could call this compute tax with $100 and the tax rate of 0.75, okay? That would compute, because that, if I made that a number and that a number and this return a number, right? If I didn't do my money thing, that would compute. I'd be in trouble, right? I probably should have done this. Let's do number, right? That, if I would have done this without having money, I could easily get my wires crossed and the computation would work and I'd get a number that was completely wrong. By making this a money, right? And saying, well, that's money, right? And then, well, so is this. And then, well, now we're right back to where we started, right? I have to put money in here, right? Like this. When I call it, I have to construct a money. So I have to say, well, this is a money with the number on the inside, right? Money, you know, this is money data constructor, taking a number as its first and only parameter, type parameter. There we go. So that's the thing of money, but I can still get, this still has the same problem. So to avoid that problem and confusion, when you're looking at a type signature, well, that's easy enough. We would just say, oh, well, let's make a new type for tax rate. Tax rate is tax rate, but it takes some money. Okay. Or maybe it just takes a percentage, right? Just takes another number. So it doesn't have to take a money, right, amount. Actually, making it take a money doesn't make any sense now that I think about it. Yeah, that doesn't make sense. Should have been just plain old number here is what I should have done, right? Then this would have been safe, right? So we actually don't need this. It's not bad. It helps. Like, I don't know what to put there. What number am I putting there? Having this thing called a tax rate and calling that tax rate, that's better actually. But for now, if I did this 0.75 like that, this would not compile because that is not a number and this is not a money. They're switched. So that's nice. 0.75 and money. Okay. So that's enough to be safe. We don't need this new type. However, I kind of like to put the new type. Helps me read the thing, understand what's going on. Puts a minor burden on us, but at least we know what we're doing. So covers those bugs. That's how I would call compute tax. So I like doing this. It keeps our data type safe, even when they're the same type. That's why it's called new type, right? So you're making a new type out of an old type, basically. Even though it acts, you're going to treat that thing exactly the same as you would treat a number, but you're utilizing the type so that you don't get your wires crossed, and when you pass it around, it works. But once you get it into that compute tax function, you're going to break the number out and use it right away. So the only way you're going to get your wires crossed is inside that function, and usually if you write small functions, it's not going to be a problem. So all right, so we're back here. We got money, we got the cost of our devices, and that's not bad, right? But let's look more at the appliances now, right? Is there anything else I care about? Well, okay. Looking at refrigerator, I'm looking at this and saying, okay, well, I can't think of anything else like cost right now. But the minute I started looking through this list, I realized, you know what? I care about some things about the refrigerator. I need information on that. Now, I can just, whoops, I didn't mean to do that. I can just put a record after here and put stuff I care about, right? This, int and that, string or whatever. I really hate that because it starts to get, this line can get really long, hard to read, hard to see all the different things. I could do this like that, right? I could do it like this and format it that way. But then these things get removed from one another. And if this thing got pretty long, it'd be pretty massive here. I couldn't just look at this list very easily. So I'm going to factor this and that out. And I'm just going to call it a refrigerator. I'm going to make a refrigerator type, right? Oh my God, I can't type that. Okay, so we'll stick it here. Okay, good. Okay, so there we have it, right? And then I'll just say, well, refrigerator takes a refrigerator. So this is a data constructor. That's why it's in red in this case. And this is a type, which is why it's in yellow. So in my particular syntax coloring that I picked, it distinguishes between the two, right? And that's a huge benefit, especially when you're first learning, to remind you, what am I talking about here? What's the compiler think I'm talking about here? Oh, this is a type, it's in yellow. And this is a data constructor, it's in red. And you see all the data constructors are in red, and then all the types are in yellow. So we're defining a type here, a data type. I'm defining a data type. I'm giving it a data constructor. That's red. Okay, so this is sort of the way that I like to do it, right? So I have a refrigerator. If I need something on the dishwasher, I'll call it dishwasher. And I can do that because the namespace for data constructors and for types are completely separate. So you can use them, you can use the same name and it might confuse you, but the compiler won't be confused. Okay. So, and syntax highlighting does help here, and you'll get used to it eventually, where it doesn't become an issue. Okay, so what things do I care about as far as a refrigerator, right? Well, there's lots of different refrigerators. Let's get rid of this and that because that makes no sense. So I want to look at different types of refrigerators. Once again, I put the underscore there because type is a keyword. And so I'm going to make a refrigerator type, right, as my type. Okay. What else do I care? Let me think. The sizes of the refrigerator and the freezer. So let's say we're going to type, let's see, fridge, cubic feet. Okay. And that's going to be a number. No, I'm not going to make it a number. I'm going to make it cubic feet. We'll come back to that. We'll make a new type for that guy. And then freezer, we'll do the same thing for freezer. That's another thing we care about, cubic feet. Okay. And cubic feet. Okay. Cool. All right. So now I've got that. What else do I, whoops, why doesn't, oh, this is a mistake I made. Can you see the mistake that I made? There's an error right here. So it can't parse it. So I told it something that it expected not to find this curly bracket. That's the point at which something I said beforehand, before that curly bracket, made the compiler not expect the curly bracket. So I needed to look before this because it can't parse at that point. And before that is this part, basically. I mean, it could be something above, but we just have our module, so that's not it. This is a data type, which you can't do like this. It doesn't have a data constructor. So if I put refrigerator here as a data constructor, then it would be fine, right? It would be happy. And notice it passed it. It can parse it. It has a problem on refrigerator type because we haven't defined it, but that's different, not a parsing problem. But I didn't want that. I wanted something that looked more like this. That has a type. So that's not a data type. It's a type alias. So when I say refrigerator, it's just an alias for this type. And this type is a record type. Okay. So that was my mistake. All right. So now let's define the refrigerator types. So this is a data type, right? Because we're going to give it some data constructors, right? So let's see here. Whoops. Okay. So what are the different types of refrigerators? So there's the French door type. There's a side by side. Whoops, side by side. And then there's, where you have the freezer on one side and the refrigerator on the other. And then there's one where you have the freezer on or bottom freezer, right? So the freezer's on the bottom, and we have a top freezer where the freezer's on top. Okay, so that pretty much. Now, is an interesting thing here is that we'll get to, oops, this should be refrigerator type. That's where I missed. That's why it's complaining. So it's complaining here because it's been declared more than once. So I'm going to save that. Great. Now it's complaining on that. Great. But let's look at this, right? French door is typically a bottom freezer, right? I mean, I've never seen a French door where the freezer's on top and you have this French door on the bottom. So they don't make those. So while this is bottom freezer, this is bottom freezer with 2 doors instead of 1. So I'm just looking at this, trying to see is there some overlap here, and there isn't. There's the fact that the French door implies a bottom freezer. Does not mean that every French door is a bottom freezer. When we say bottom freezer, we're talking about freezers that don't have double doors. So this, I'm just going to put a little comment here to remind us, is a single refrigerator, right, door. So that's the difference. This is a double, right? That would be a double refrigerator door. Okay, so that helps. These are single, obviously, and this is single. But I'm going to put comments on this just so it kind of reminds me of, because these are the two that could be confusing. This has a bottom freezer. So this will just say with bottom freezer. There are no French door top freezers. If they did create them, then we would probably have a thing called French door bottom freezer, and then French door top freezer, and as an additional type. Now, granted, we'd have to go through our code base and fix that. The compiler will complain, so it helps us do those kinds of refactorings, which is nice. But I don't foresee anybody building such a thing, so I think we're pretty safe in sticking to this just generalized type without having to say bottom freezer afterwards. Okay, so I think those are the only ones I know of. If something else comes up, we easily can just add it to the bottom of this list. Okay, so now let's go to cubic feet. And that's a simple new type. We define our new type. So cubic feet equals cubic feet. And it's a number because sometimes you'll have like 25 and a half or 25.8. So that can be, and that 0.8 can be important if you're comparing apples to apples. And you're like, well, all things being equal, I'd rather go with the 25.8 over the 25. So having that little extra bit of information is going to be important. Okay, so we have our fridge cubic feet and we have our freezer cubic feet. Okay, so anything else? So that's the question you always ask. All right, what else? Right, what else? What else is better than anything else? Because anything else is a yes, no. But what else forces our brains to search for something? A lot of times I like to tell people, okay, so this is it. This is all you will ever need to know about a refrigerator from this point forward till the end of time. And people love to like prove other people wrong. So it's kind of a game. So this gives them the opportunity to prove me wrong in that statement that I just made, that this is everything. And so if you're working with someone who isn't very good at giving you specs, that's a really good approach I found. As you say, all right, so this is it. This is you're never going to want to know anything else in this application about a refrigerator. We have listed everything. And then people start to panic. They think, oh, what? Wait, this is it? This is all I get? Let me make sure. Wait, I better start thinking. And they'll look for something. If you're working with someone who's, collaborative, another developer or a team, you're doing this on a whiteboard session, a lot of times you can say, okay, what else? And you look to the room and you hope somebody can come up with something else. And or if you're just doing this by yourself, you can say, all right, what else? What else? I got this, I got that. What else? What else is there and just keep asking yourself, what else? To keep, in the interest of time, I'm going to move on this one. I'm just going to assume that, yes, I've asked that question and yeah, we've got it. Everything's good. Dishwasher, I can't really think of anything for that. Oven's okay, we might come back to the dishwasher. I don't know. Let's go to oven, right? So oven, there's some things about ovens that I can think of pretty quickly. So I'm going to skip dishwasher. Maybe I'll come back to it. Eventually I should go to each of these, right? But we're just going to do, this is just for learning. So we're just going to do what we can think of easily. So I have an oven, right? Now, there are different types of ovens, right? So there are, let me think, there's a single, well, if we follow the pattern we've been doing, we call these types. So I have a single oven, right? So single oven. I could call this single, assuming that nothing else is in this file is called single. No other data constructor is called single, and it doesn't look like there are. So I'm just going to call that a single and a double. Yes, naming is so hard in programming. So I don't know. If I just see single, it doesn't tell me a whole lot. I'm going to put oven here, but I don't have to. But I kind of like it in this particular scenario. Each scenario is going to be different. So I would look at this and say, Yeah, if I just saw single and double, I wouldn't know what the heck that meant. So I'm going to put oven after it. And that's our types, but we really want to define the oven type alias. We're going to use the keyword type here. And it's going to have a type, right? Here's the keyword type, and here's our variable type with an underscore, since we can't use it without one. And it's going to be an oven type. Okay, whoops, oven type. Okay, so what else about an oven is there? So let me think. What else? Well, let's see. I know. So some ovens are electric and some ovens are gas. So let's call that what? Energy source? Blech. That's a horrible name. I mean, it's not bad. That's a lot to type too. I don't like it. So I'm going to call this fuel. Okay. And we'll just have a type for fuel. Okay. And I'm just going to put my fuel type. And the fuel is going to be, let's see, gas or electric. Well, now that I've written that and it's called fuel, can you think of another type maybe? So the question I would ask is, what else? The old wood burning stove, right? So we have maybe you have an old stove, right? Or it's a stove on a farm or something like that, or just a retro stove, and you want to cook with wood. So yeah, that's a possibility. Less likely than the other two, but that's worth putting in there. Okay, so our code will support this extra feature now. All right, so what else about our stove or oven, right? There's lots of different types of ovens, and so and the type of oven, like we have that here for a single and a double as our type. So there are other kinds of things that ovens, like some ovens will steam and some ovens will do convection and things like that. So I kind of feel like I could make a bunch of types for that, right? I'd have single oven steam, convection. I'd have single oven broil, single oven roast. And then I have to do all the same ones for double oven. And it just becomes this massive list of types. And I kind of don't want to do that. And some ovens do some things and don't do other, so there's this kind of weird mix. This would be a nightmare. I like this simplistic. I worry about, is it a single oven or is it a double oven? That's enough. Here, I would like to know its cooking features, right? Now, it's not I don't want to make this an array of cooking features, right? The reason I don't want to make it an array is because that means that whatever cooking feature is, I could have like an array of 1,000 things and it's the same cooking feature. What I want to do instead is make this a set of cooking features, right? We haven't defined either of these things. A set is something I can import. I can import that from data.set from standard library. Okay, so now compiler knows what set is. Sets are like they were in school. You can only have one thing in a set of that type. So if you were to take two sets, they both have the same thing. They both have, let's say, they both have steam in them, right? So you have set A and set B. They both have steam. You union them, you wind up with a set with only steam in it. So sets remove duplicates. They don't allow for duplicates, right? They eliminate any duplicates. So you can't have 1,000 things in that set and they're all the same. They're all going to be unique. So that's the perfect thing for that. And now we're ready to go on to our cooking features. So we'll do that. Whoops. Oh boy, I keep hitting the wrong key. There we go. Okay, so our cooking features. So what are those? What did I say? I said broil. So we have broil, roast, we have steam, and convection. Nice. Now, we could have microwave here, right? That's a possibility, but we already have this microwave oven down here, and they tend to be a completely different device. I don't know a lot about ovens, but I don't know of any oven that has two of these or more features and also can microwave. So a microwave oven might be able to have like a heating element on the top. So we could do something with that when we flesh out microwave. But for this kind of oven that's gas, electric, and wood, I'm thinking I don't want to put microwave here. It's possible. One could argue. I'm not going to take the time now to go look and do the research, but if I was really building something, I would, and make sure that that thing doesn't exist. If it did, then I would put microwave here as another cooking feature that you could use microwaves instead of convection to cook the food. Okay, so now we have our cooking features. What else? That's the question. I can't really think of too many other things. So, all right. I mean, really, if we were doing this for real, we would spend more time on this. But the idea is to see what the process is like. So let's move on, and we're going to dig into you know what? Let's do dishwasher, right? And let's look at the things about a dishwasher, right? So appliance as a type. Yeah, okay. So dishwasher. So what do we care about as far as a dishwasher is concerned? Well, did the wrong thing. I'm doing a type alias because I'm making a record of things that I care about for dishwasher. Okay. So what do I care about? The type of dishwasher. So let's think about that, because we've done that with other things. We did it with oven and we did it with refrigerator. Are there different types of dishwashers? I mean, significantly different types of dishwashers. Now, I don't know a whole lot about dishwashers, but anyone that I've ever seen that don't really think there's some hugely some huge type differential. So I'm gonna say probably not. Let's see what other. Well, they all heat, and it might have a water softener, or it may heat up the water. It's have a built-in water heater and things like that. So let's just call this features, right? These are, because there aren't these major differences, but there's these minor differences, and so most dishwashers are the same, but some have these different features. And once again, we'll do a set, right? Just like we did for cooking features, and we're going to call them dishwasher features, right? Just like we did before. All right, so I got to define that thing. Let's do that up here, and that's going to be a sum type, right? Because it's going to be, our any dishwasher features. I shouldn't have called it features. These shouldn't be called features. They're not. Plural doesn't make sense in the type. It makes sense in the name of this because it's a set of those, but each thing is one feature. So that's my mistake. We will fix that and fix that here. Okay. I tend to make that mistake from time to time. So, okay. So dishwasher feature. So where are we on that? What did I say? Oh yeah, soft water and heater. Okay, that's something. All right, so now I'm looking at this going, what else? What else what other things about a dishwasher? I would say number of racks. Right? Rack. Oh, gee, why can't I spell? Okay, number of racks. Some dishwashers have 2 racks. They've got the bottom one, the larger one, and they have a smaller one. And other ones have this 3rd rack on top for like flatware or large other utensils and so forth. So 2 or 3, right? Number of racks. Now, this could be negative. It could be 500. It could be all kinds of things, right? We're looking at a very small number of possibilities there. So I'm going to do this. Rack is going to be 2 rack or 3 rack. I'm pretty sure there's no 4 racks. I recently was looking at dishwashers and I never saw a 4 rack. So this would be, right? So that would be of something of type rack, okay? This way we don't, the goal here with types is to restrict the possibility of bad values, right? And that's the number one thing for types. And it helps us, it helps the compiler, it helps us, it helps us not to make mistakes. When things aren't typed, you can put anything in there. And that's why dynamic languages are so dangerous when you're, when you're putting complex systems together, because you can't guarantee certain things. You can be as disciplined as you want, but you will always, always, always make a mistake. And who knows where and who knows when it'll pop up, because it's not compiled, it's a dynamic language, and it's dynamically typed. So I can put anything there, and then I go try to use it, and I get in trouble. And it's just a piece of code that only runs once a month, once a year, or in some weird edge case, I may not find that bug for 2 years, and it's been sitting dormant in production, just waiting to go off. So this isn't much better. Even though with a type int is saying, well, it's an int, but that narrows it down, but just didn't narrow it down enough. And since we only really have 2 types here, we have a 2 rack or a 3 rack. I don't think there's a 1 rack, and I'm pretty sure there's no 4 racks. I think this is a perfect example of when we want to make that particular type. So, okay, so let's keep looking. Let's see, what else? I kind of feel like this kind of says it all, right? We'd want to do stove next, and we want to do range and microwave. And then, of course, I'd want to dig down into each of these and see if there's anything special about these that we want to keep track of. I'd ask the question, did I miss something in my large appliance? I'd sleep on it, come back the next day. What did I miss? I would want other people to code review this, right? Don't need this anymore, right? So I wouldn't want to give them that in my code review and see all my mistakes. I would want somebody to go over this, think about it. I'd ask them the question, okay, this is it, right? This is the only thing an oven can have. There's nothing else an oven has that I care about when I'm remodeling my kitchen. There's no more information I want to keep track of. That's it. And they would say, well, what would it cost? And I'd say, oh, no problem. Remember that this oven up here is a parameter to this oven, which is a large appliance, which is a parameter to the appliance type, which is in our appliance, right? So every appliance has dimensions and cost. This is sort of our common appliance information. And then specific information is in this appliance type. So that's where that's taken care of. So once they understand your model and how your model is structured, then they can help you to try to fill in some of the blanks. And that's a really important thing to do. If you have to work on your own, then review it, come back to it, sleep on it, try those kinds of techniques, and see if those, if like a good night's sleep helps you look at it and not be so tied to your design, right? You might find that you want to restructure this in some way. I don't know. There might be a better way to restructure this. New requirements come along, you might want to restructure, and that can have a huge impact on your code base, and even worse, your database. So if you're storing JSON into your database and you're taking these types and you're encoding them in JSON and putting them into a database, you're gonna run into trouble. So you want to really start with your model and then start looking at how your code's going to be used and what operations you're going to do, and make sure your model can support all of those things. This is the stage when you're doing your coding and you're coming up with your requirements for the code and what users need to do, where you're going to start looking at this and going, oh boy, this isn't going to work, or this is going to be really hard for me to do that operation because of the way I structured this. If I structured this differently, that would allow me to do something else, right? So for example, I may have somewhere in my code, I have an array of appliance, right? And okay, that seemed like a good thing at the time, but now somebody wants to search for all of something, and now I'm like, oh, well, that's a problem, isn't it? I got to search linearly through this big list. Let's assume it's large. maybe I should make this a map instead. So a map of an appliance, and then it would have an appliance type, right? But that assumes you only have one refrigerator and one dishwasher and one of everything if I do that. So you I don't know, is that a requirement to have more than one? Well, we don't know. So better safe than sorry, I'm going to have an array of appliance here. So I'd have a key here, and then I would have to do a much shorter list, most likely a list of one for the one refrigerator. In the rare case, someone wants to have two refrigerators in their kitchen, then I'd have to look through a list of two, right? So if we pretty much know that this is just based on experience, you talk to your subject matter expert and they say, no, I never, I've done this for 10 years now and I've never had anybody put two refrigerators. Okay, then you could just say, okay, then that would work just fine, right? There's only one appliance. There's only one refrigerator in the map, because the map is just like a set, except it has a key and a value, and a set just has a bunch of values. So the key, you're only allowed to have one key, right? One thing in the key. So it's a key value pair, if you want to look that up, if you don't know what that is. It's a key value pair. And so that's why we'd only have one appliance. If we wanted to have multiple, then we make the value a collection of refrigerators or dishwashers and so forth. So it's probably not worth it in most cases. But this is where things, in the stage of trying to figure out what the operations are, you look at your model and you really ask the questions, does this model support those operations? They may not. Like I said earlier, if this was just an array of appliance, I'm going to be looking through this list and looking through this list and looking, where I can just say, map.lookup, boom, and I get the thing right away. Instead of, having to have the computer, look at the first one. Is that it? Nope. Look at the next one. Is that it? Nope. How about the next one? Maps are far more efficient, especially if these things are large. It's really important. And you never know. I mean, you might start small and it might grow large, so it might make sense to go through a map. So these are the kinds of questions that you're going to ask yourself as you're going through and getting, fleshing out your system. And since modeling should really happen first, in my mind, it's going to change. This is not enough. I mean, we didn't finish it, obviously. We're just going to do more of the same here. And then once we got done, we'd be like, okay, that's it. And now let's move to the next stage, and that's getting it reviewed and making sure that it makes sense, and then understand the operations. And then you look at those operations, look at your model, and make sure your model is going to support those operations and make your job easy. If it isn't going to make it easy, then you need to modify your model. Do it now. Now's the time. And now you know all the different operations. These are all the things I know that we're going to do. And then what things are potentially possible in the future. You want to make that list and compare your model against that. And then you have to make decisions like, how likely is this thing going to happen in the future, right? If it's highly likely, then yeah, definitely change your model now. If it isn't, then think about it. What's the cost of changing your model later when you've got all this code and you might have data in a database? What's that cost compared with the probability? If the probability is very small, 5, 10%, then the cost can be higher, before you change your model, right? So the cost could be, well, it's going to take 2 man days to do this, or 4 man days to do this. But the probability is so small that it's not worth it. And if I make the model change, I'm going to be burdened with that change in every case, except it may never happen. That requirement may never come true. So it's not worth it to me. So you have to make those kinds of judgment calls. But this is the way you start. You start thinking about how to build a model, and then, like I said, you compare every other requirement against your model. Make sure your model is properly represented. And if we were going to do some other app with kitchens, like a store that kept kitchen appliances, this would look very different. This would, well, not 100% different, but there might be other things like features that we thought of may not be. It's like, yeah, these aren't the only features, because we have a very large inventory, and they have all these specialty dishwashers or something. So there might be other things that are more important for an inventory application than it is for someone who's just trying to create an app to help people keep track of their choices as they remodel their kitchens. So each application's requirements will put its own spin on this. There is no definitive model. So it's really, and there's many ways to skin that cat. So you could have come up with something completely different. I actually ran through this before I made this video, and I'm looking at my notes down here, and I'm like, oh, I did it a little bit differently. I look at that, I look at this, and they're equivalent. And so I'm going to go with what we did up here. So there's, like I said, lots of ways. So hopefully that's been helpful. If you want to learn more about types and everything, like I said, there's a lot of stuff coming after Chapter 3 where I do touch on types and these sort of things. This I didn't really do in the book. The book's big enough. This is something that's a nice supplement as a video. So I thought, yeah, just keep that out and we'll do this here. So hopefully that's been helpful. And this is basically something that you can really get your skills up on and try this yourself. So you might want to pick if you want to do this and just for fun, like, I don't know if people want to do this for fun, but I kind of think it's fun, is just take a problem set that you know really well, and how might you come up with your own models for things. Modeling things is so important in software development. We sort of are scientists in that way, where we create models, and or physicists do that, and I mean many scientists do. But you create these models, and getting that model is really going to help you understand your problem, and that's the number one thing that we need to do when we're before we can write software for somebody to solve their problem. So anyway, so this is a supplement to Functional Programming Made Easier, a step-by-step guide. So I hope that hope you're enjoying the book, and I'll see you next time. Thank you.